Check one, hurry. Begin there. Hello, good evening. Hi, Bhuvan. How are you, people? Komada. How are you? Right, people, today thought of go through a quick revision on chemical basis of life lesson, right? Now we have to take time rapid revision, right? So we'll discuss today what we learned in the class sometime back, a couple of months ago. So we have to practice this. I'll be giving you a paper based on that. I'll be giving you a paper based on this. All right. So a paper based on this. So we'll discuss this paper next Thursday, right? So I'll be explaining you, revising with you certain sections, and then week after, I'll be giving you a paper on that. Now, this coming Saturday, I'll give you the paper. So you have to answer it. And then week after, we'll be discussing that paper, right? So week after week, we go like that. So that's the plan. And right, people, chemical basis of life lesson. Chemical basis of life lesson. We did long time ago, ne? Right. So today my plan is to discuss carbohydrates, elements, and then what's next? Carbohydrates, and then we have to discuss lipids, ne? Right. Then proteins and nucleic acid we'll take into next class, right? So likewise, we'll go through rapid revision. So elemental composition of living matter. Elemental composition of living matter. Elements. Now you learn, people, 92 elements are present. 92 elements present in organisms. 92 elements present. Right. 92 elements are present. And then we said that, people, out of those 92 elements, we said that some elements are present. 92 natural elements, 92 elements, we said that they are natural, right? Elements, how many? We said, people, 118, 118. Out of that, we said, people, 92 natural, natural elements. Natural elements. How many we said? 92 are natural elements. And then we said, people, living matter. In living matter, some elements present, right? Out of these elements present in living matter, essential elements present. Essential elements. These are required for living processes. We said what proportion is essential, people? 20 to 25% of the natural elements. Stuck 20 to 25% of the natural elements, they are essential. So 20 are they are essential elements. What we said, people, in plants and human, we said human, human 25 elements essential. And then people in plants, we said plants, how many people? About 17 elements present in plants are essential. We said people out of this set, um, some elements present more than 96%. We said carbon, hydrogen, oxygen, nitrogen. Carbon, hydrogen, oxygen, nitrogen, they make up about 96%. And then the other elements we said, the other elements make the remaining 4%. Other elements make the remaining 4%. From the remaining 4%, we said carbon, sorry, calcium, phosphorus, potassium, sulfur, right? From this, right? Calcium, phosphorus, we wrote it in this way. Uh, PKCAS, phosphorus, potassium, calcium, and sulfur, right? So these are the, from those 4%, the major ones are these four. And then we said people, then present in minute amounts, minute amounts, present in minute amounts. What is the list we said? No call, co-crow, mage, beef, kufe. No call, co-crow, mage, beef, BIF, beef, kufe, ne? No call, co-crow, mage, beef, kufe. We said that. So this is what we learned about elements, right? And then we discuss physical and chemical properties of water. Physical and chemical properties of water. Physical and chemical properties of water, right? So this is our next topic, physical and chemical properties of water. Right, we learn people, water is a vital inorganic molecule. Life cannot exist on planet without water. And then you learn people, vital chemical constituent of living cells, water, provide biological medium for organisms. Vital because it's a need for life. You can't survive without water because water is a reactant as well as it's the medium of your body. And physical and chemical properties of water. We said people physical properties. What we said physical properties? Without change in the chemical nature, if you can experience some property, that's physical. And with the chemical change, if uh, with a chemical change, if with a chemical change, uh, then you call it as the, oops, with a chemical change, okay, then you call it as the physical property. Now the camera moves, it tracks me, I can't switch it off. So, oh, right. So this camera is moving. Sorry about that, people. I don't know how to stop that. Right. It's now moving. Tracking stop. You know what happened with that? Okay, that's really disturbing. It's going to turn, right? It's going to turn this side. It's not going to work, ne? Right. Then people, we have to discuss about water. Right. We have to discuss about water. Right. It's like a movie. You know. We have to discuss about water. The camera tracks me. That's the problem. I can't switch it off. Just give me 1 minute. මේ කැමරාව එක ට්‍රැක් කරන ඔටෝමැටිකලි එක පටන් ගන්නවානේ. ඔටෝමැටිකලි පටන් ගන්නවා. P2 ගැහුවට නවතින්නේ නැහැ. P2 ගහලා සෙට් කරාට ඒක මෙතන සෙට් වෙන්නේ නැහැ. ඒක නිකම්ම ආවේ. මේ ඔටෝමැටිකලි ට්‍රැක් කරනවට. Right, people will go to right, we'll go to talk about water, ned? Water. So what we learn, people, about water? Water, we said that vital inorganic molecule, right? And then life cannot exist without water. We discuss those things, and we talk about, people, physical properties of water, ne? Physical properties of water. Physical properties of water. Right. Physical properties and chemical properties. Now we can see that water hydrolyze, releasing OH and H plus ions. That's like chemical property. Ne? That's a chemical property. It's not physical. Then we learn, people, 4 physical properties of water. Cohesive behavior. Ne? We said first one. Physical properties of water. Physical properties of water. What we discussed, first one, cohesive behavior. Number 1. Cohesive behavior. Cohesive behavior. Right? Water molecules, they attract. That is cohesion. Addition and cohesion, we talk about it. Right? Now, this cohesive behavior is helping in transport of water inside the plant. Also, you learn, people, this is maintaining the surface tension. Number 1. So, cohesive behavior is helpful to act as a good transport medium. Transport water in xylem. Right? Water transport in the xylem depends on that. Right? And then second one is, so conduction of water and dissolved substances in the xylem against the gravity. Right? And then second one, people, we said water molecule attractions are providing what do you call the surface tension. Right? Surface tension. Right? So second one is surface tension. Surface tension. And then due to surface tension, what happens? Water surface now act as a habitat for some of the organisms. So they can walk on the surface of water, right? So that's both comes because of the surface tension. Sorry, the cohesive behavior. Second, we discuss, people, ability to moderate temperature. What is the second one? Ability to moderate temperature. Ability to moderate temperature. Now you learn 2 points under that. What are those 2 points you learn, people? One is high heat capacity of water allow living systems to heat up slowly. So all water containing bodies, it can be living organisms or it can be water bodies, they heat up very slowly. Second one, what do you learn, people? We learn that the latent heat of vaporization. And then evaporation, high heat of vaporization. High heat of vaporization. Because of that, when small volume of water, small amount of water, when it evaporate, we said that people, it absorbs a lot of heat from the body, right, to break the hydrogen bonds, right, bone breaking. That's the first time we talk about bone breaking. That absorbs energy. So as a result, it's going to cool our body. So we'll take those two special points. What are those two people? First one, the we talk about high specific heat capacity. High specific heat capacity. High specific heat capacity is going to absorb a lot of heat, right? Absorb a lot of heat. And then, high heat of heat capacity is slowly heat up. Even if a lot of energy is applied, it's going to heat up slowly. So high heat capacity. Second one, people, high heat of vaporization, right? High heat of vaporization, right? So because of this high heat of vaporization, right, with loss of small volume of water, large amount of heat can be dissipated from the body. That is what we discussed. Third one, people, we learn as third one, expansion. Expansion upon cooling, upon freezing. Expansion upon freezing. Freezing. We learn, people, most of the compounds, as it cool, there is a volume decrease continuously. Even if you take metal, even if you take concrete, people, decreasing of temperature decreases the decreasing of temperature, right, decreases the volume. So is that the Himayane, Sidhuana Thapa Prasarane? Himayane is the freezing point. Sidhuana Prasarane, oh, ekahari, for water, so water, it behaves in a different way. That's correct. Are you reading Sinhala resource book? That's nice. Expansion upon freezing, right? Normally other materials, upon cooling, the volume is going to decrease. But at water, up to down to 4 degrees Celsius, down to 4 degrees Celsius, we can see that down to 4 degrees Celsius, we can see that there is the decrease of the volume. So therefore, the cooler, the density increases. But below 4 degrees Celsius, something unusual happened. Water molecules start organizing, right, properly by maintaining a fixed distance below that. So there is a volume expansion. Especially, people, upon freezing, it goes into a lattice. It goes into a lattice. So when it forms a lattice, what happens, right? When it forms a lattice, then we can see that there is a volume expansion. So we'll take that point. What has a minimum density at 4 degrees Celsius? So below 4 degrees Celsius, upon forming a crystalline lattice, the volume expands. Right. So expansion upon freezing. So we learn, people, this is helping to maintain liquid water during the winter. When water bodies, right, when during the winter, water body does not freeze into solid, and only the surface water solidify and keeping liquid water at the bottom. So that is the advantage. We can take that we'll say that, people, this property is helpful in polar region for organisms to survive during winter. Right? Help organisms to survive during winter. Right? Survive during winter. And then last one, we said, people, versatility as a solvent. Fourth one. Versatility as a solvent. Versatility as a solvent. So it's good as a solvent. Why, people? We learn that water dissolves different things. Ne? Organic compounds can dissolve in water, and then ionic compounds can dissolve in water. Inorganic materials can dissolve in water. So it's a nice solvent, right? Polar and ionic compounds, they can dissolve in water. All right. So that's an advantage. Ne? So it's good as a solvent. And therefore, so many materials can transport in water in dissolved form. So that's important, right, for life. And so we learn, people, um, polar compounds are soluble, ionic compounds are soluble, and ionic and polar, both properties present in some of the molecules like protein, some proteins. What is the protein that we learn, people? What's the protein? Fine. So it dissolve ionic compounds and what do you call polar compounds, and then polar ionic compounds. Ne? Polar and ionic compounds, they are soluble in water, right? So those are the things that we learn regarding water. And if you have questions, I don't think you have any questions. Ne? You don't have lysozyme. You mentioned that lysozyme. That's good. So they are soluble. So look at this, people. Look at this properties of water. So you learn the bond angle, the 104.5. So these are important. You might get those things in your next paper, right? Your first paper. So we'll start this paper series very early, right? So we have done you. Uh, 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 uh. It's taking my hand gestures. It's taking my hand gestures. When I move the hand like this, that's the thing. Ayyo. I didn't do anything, but it takes my hand gesture up and down. And that's it. That's the reason. Oh, yo. I have to check the catalog for that. I have to check the catalog for that. Now it's not moving. That's the reason. Taking the hand gestures. So I like talk without moving using my hands, right? Look at this. Water molecule is small polar angular molecules. Polar is uneven charge distribution within a molecule. In water molecules, oxygen atom is slightly negative and hydrogen atom is slightly positive. Weak attractions between slightly polar hydrogen atoms of one water molecule and slightly polar oxygen atoms of adjacent water molecule are known as hydrogen bonds. So you know that, right? It was say these hydrogen bonds play a role in maintaining properties of water. So you know, people, these hydrogen bonds, they form and break. For a second trillion times, these bonds can form and break. So therefore, they are not permanent bonds, right? They are temporary bonds, right? They are not permanent bonds. They are temporary bonds. All right. And so hydrogen bonds are going to be helpful. And then properties of water arise due to hydrogen bonds between different molecules when the water is in liquid. When the water is in liquid form, these hydrogen bonds are fragile. But hydrogen bonds are going to be, people, quite stable when they go into the crystalline structure, ice. When it solidifies, it becomes somewhat stable type of bonds. So that is why they emphasize here, hydrogen bonds are very fragile at the liquid state, right? So that word is important. Because if they say that hydrogen bonds are very fragile in the crystalline stage, that is then a wrong statement, right? So A level, this is actually people what do you call it, a challenge, because you have to remember those words, right? Always, sometimes, words, right? So very fragile. I think it's something that you need to highlight, right? Okay. Physical properties of water. Four major properties are cohesive behavior, ability to moderate temperature expansion upon freezing, and versatility as a solvent, right? Then we come for this part, cohesive behavior, right? Attraction between water molecules due to hydrogen bonds known as cohesion, attraction between water molecules and other substances known as adhesion. Both of the above properties of water allow it to act as a transport medium, right? Act as a transport medium. Due to cohesion between water molecules, water and dissolved substance such as minerals are transported in continuous column through the xylem against the gravity. Addition between water molecules and cell walls also help to conduct water and dissolve substances. Water has high surface tension. This ability gives the water molecule to due to cohesive behavior. And that's important, isn't it? Now, if you think of people, the surface tension comes due to cohesion. Surface tension comes due to the cohesive forces between water molecules. So what happens when water attract? Then this is providing the ability for the organisms, light organisms, to walk on water. You tried that, neither, right? I'm sure you tried that to float a needle on water, ne? So it's a different type of physics there, right? Not the what you said, Archimedes theory, ne? It's not that. Right? So a different one, ne? Ability to moderate temperature. Ability to moderate temperature. So we'll read that, neither. Water can absorb or release relatively high amount of heat energy by slight change in its own temperature. Due to high specific heat, water will function as a thermal buffer, right? So thermal buffer means what? What is a buffer? Now, buffer is something which can, right, maintain certain property at a constant level, that you call as a buffer. Right? So water is acting as a buffer to maintain the fixed temperature in the body. Neither. And then due to high heat of vaporization, with the minimum loss of water, organism can release much heat. This helps the organism to cool their body surface and prevent from overheating, right? So you don't get overheated. Evaporation of sweat from the human skin to maintain body temperature. We learn about the evaporation and transpiration, neither. So transpiration is evaporation of water from the plant body, and you say perspiration, neither. Evaporation of water, right? As sweat, we call as perspiration anyway, right? So vaporization is something different. You learn the difference between the vaporization, evaporation, transpiration. I think you know that, right? And then people expansion upon freezing, generally in an increasing in temperature of any substance, reduce the density, and on the other hand decreases the temperature, increase in their density. When the temperature of water falls below 4 degrees Celsius, it begins to freeze and forms a crystalline lattice called as ice cubes. Water has maximum density at 4 degrees Celsius, hence ice float on the surface of water bodies. It is an important property of water in polar regions, where organisms in aquatic bodies can survive during the winter, right? Okay, so that's it. So we are moving to next one, versatility as a solvent. And this ability is given to water due to their polarity, polar molecules, glucose. You know, people, polar molecules. What are polar molecules? What do you call polar? Usually we said people, the oxygen or nitrogen containing compounds, they have high electronegativity in the oxygen and the nitrogen atoms. So therefore they attract, right? Because of the high electronegativity, they attract the, what do you call it? They attract the electrons towards that, bond electrons. As a result, there is a charge separation. There is a charge separation that we call as the polarity, And then this polarity, right, is different to ionization. Ionization, we can see that it break into ions, the bond break, and then the electrons are either lost or gained. This is not like that, right? It's just like a holding electrons. Bond electrons are kept more around one atom. Electronegativity. You have learned these things, ne, for O-levels, as well as maybe you are learning these things for chemistry also, ne? Right. So what happened, people? Water molecules surround each of the solute molecule and form hydrogen bonds within them. Therefore, solubility of the solute depends on the polarity, not on their ionic nature. Remember that the solubility is of water, right? Versatility has a solvent. Water is a good solvent because of the ayyo. Water is a good solvent. I don't know what to do for this. Water is a good solvent. What to do for that? Okay, we'll give him a command and see. Oh, okay. All right. All right. Okay. I learned it. Learned it. Learned it. Learned it. Okay. All right. So this is P1. This is P1 camera. All right. Got it. Right. So MCA paper or full paper? No, we can't do full papers, right? My plan is to give you my plan is to give you what's this? Right. I can't lift my hand up. I can't lift. Right. I have to talk without moving my hands. Right. I can't scratch my nose. I think I can scratch nose. Right. So we will do it. We'll do it. 15 MCQs, one structured, one essay. That's good, ne? Right? 15 MCQs, one structure, one essay. How is that? It's not an exam. Don't take it as an exam. No, it's not an exam. We'll give you the paper, you answer it, and you submit it. You have to submit it. You have to upload it to the website, and we'll be marking it, right? And we'll be giving the short notes, short notes as a gift for those who study well and then score. Like last time, whoever wrote the essay papers, I gave them a gift, Children's Day gift, short note, right? Same thing I'm going to do, right? So it's a small paper, okay? You can do it. Maybe it'll take 45 minutes for you to do it, and then you can just submit it. You submit it online, to our website, and we'll mark it and then show you marks, right? It's not something serious, right? Something light work. Okay, right. So that's I'll give the paper on Saturday to you. Saturday, I'll give you the paper. So you take it home, do it, and then submit. Okay, and then week after, I'll give you the marking scheme. So you do it. So then we'll discuss, and then you can right. We'll can go for a next section. You can suggest me difficult sections, right? It's maybe I'll go with that, right? I'll tell you the sections, you study it, and then we'll do it. All right. You can give some suggestions too, right? But anyway, your papers are already fixed, so I have to go according to that, right? So I'll tell you the sections early, you just study it, and then we'll discuss it, and then you answer it, and that's all, right? We'll mark your papers, and based on your performance, I'll give you small neither gifts, small short note gifts, right? Okay. Now, people, chemical nature of organic compounds, carbohydrates, right? We'll discuss carbohydrates and lipids. Carbohydrates and lipids. Come this side. Right, carbohydrates and lipids. Right, carbohydrates. Carbohydrate, neither. We learn carbon, hydrogen, oxygen containing compounds as carbohydrates. Carbon, hydrogen, oxygen containing compounds are carbohydrates. So we can classify carbohydrates. We can classify carbohydrates. How do you classify carbohydrates? Yeah, we learn this, neither. Carbon, hydrogen, oxygen containing compounds. What you said, people? Carbon, hydrogen, oxygen containing compounds are carbohydrates. What is the formula? CxH2OY. We learn, people, X can be equal to Y. Sometimes X is unequal to Y. Right? You learn in some X is equal to Y. In some X is unequal to Y. Right? X is unequal to Y. Right? This camera does not take hand gestures. That's a nice one, ne? Right? The other camera is like 3 times expensive than this one. This one is around 44,000. The other one I spent nearly around 100, yeah, almost 100,000. Ne? So it's not 3 times, but nearly more than 2 times. But this is better. Sometimes neither. The perfect student is not the best student in the class, right? Good and bad things are there, right? Now look at these people, carbohydrates. We classified carbohydrates. How do you classify, people? We classified carbohydrates as sugars and polysaccharides. Sugars and polysaccharides. Look at these sugars and polysaccharides. Right? Sugars and polysaccharides. Sugars we further classified. Monosaccharides and disaccharides. Monosaccharides and disaccharides. Right? Monosaccharides, we said 1 sugar unit. Disaccharide, we said 2 sugar unit. Polysaccharide, we said many sugar unit. Formula also we discuss differences. Formula. We said, people, even if they have this formula CxH2OY, when come to monosaccharide, how do you take the formula? Can you type and send me? How do you take the formula? CH2ON. 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 Right? That's the formula, CH2ON. Right? And then disaccharide, what do we said? C12H22O11. Right? So this is disaccharide. Polysaccharide, people, the same. CXH2OY. That we can take that formula. Now you learn a list of monosaccharides. What is the list of monosaccharides? That's like something new, ne? List of monosaccharides are there. So website is more complicated to handle. I couldn't get the previous week recordings yet. I think last week recording upload, there was some issue. Sorry about that, people. We are doing certain developments. So then some components we lose because of these changes. We can't go without changing because there are continuous challenges and new additions. We do updates, we have to go with that. But we'll try to minimize and at one point we'll come to a settlement. But there are certain things to do in coming time period, because we try to give the physical students and the online students some equal facilities for them to use the website. So it's little challenging at the moment, uh, right? So we will try our best to settle down everything as soon as possible. So until that, please tolerate a little bit. It's like a house construction, or thing that they construct house and then while you are living in it, so then you have to like move your cupboards and then your bed and then pillows, you have to cover them. When the bausunai come and work, this is something like that. While it's working, we have to do the adjustment. So sometimes certain problems appear. So please tolerate them for a short time. We'll be finishing it soon, right? Right now, what we discussed, people, polysaccharides. Then we have a list of polysaccharides. What is the list of polysaccharides? Can you help me write that? Starch, neither. Starch, glycogen, cellulose, Fourth one, come on, help me to write the list. Inulin, pectin. What is the next one, people? Lignin, peptidoglycan, ne? Peptidoglycan. Seventh one, lignin. So glycogen, cellulose, inulin, hemicellulose, I missed that. Chitin also, ne? Hemicellulose, chitin, ne? Chitin, AGA. AGA also we took into the list, AGA, right? Lignin we didn't, we took that, ne? Then 10th one, AGA. So 7, 10, altogether we discussed 10, right? So this is a polysaccharide list. Monosaccharide, people, we had a list, glyceraldehyde. What we said, glyceraldehyde, erythrose. What's the next one, people? Erythrose, ribose, deoxyribose. Fourth one, what is that? Ribulose. Fifth one, glucose. Seventh one, galactose. Eighth one, fructose. Right? So that's the monosaccharide set. Disaccharide set only 3, ne? Disaccharide set only 3. What are those 3, people? Only 3. What are those 3? Right? Maltose, sucrose, lactose, ne? Maltose. Number 2, sucrose, lactose. Maltose, sucrose, lactose. Right? So those are the 3 disaccharides. Right? So this is the list we discuss. This is the list. Right? Now we said, people, these monosaccharides are variable. Monosaccharides are variable depending on the number of carbon atoms available. Number of carbon atoms, 3 carbon triose, 4 carbon tetrose, 5 carbon pentose, 6 carbon hexose. And then you learn further, people, depending on the type of carbonyl part. There are 2 types: aldose, glucose, galactoses are aldoses. Ketose, fructose is a ketose. Right? Fructose is a ketose. All right. So let's focus on these monosaccharides. Let's focus on monosaccharides. Let's focus on monosaccharides. Let's focus on monosaccharides. Right. So 3 carbon, 4 carbon, 5 carbon, depending on the carbon number, we can classify them. Depending on the carbon number, we can classify. But you learn, people, when you say a monosaccharide, let's take C3H6O3. When you say a monosaccharide, 3 carbon atoms available according to this formula. Neither. So 3 carbon atoms available. Then you can take 3 carbon containing monosaccharide. It has 3 oxygen also. One of the oxygen is having double bond. One oxygen has double bond. Right? And then the hydrogen you share with the remaining. So this is the structure. We learn, people, there is an isomer here. Isomer is the similar molecule, right? Structural isomer. Same formula, you can draw another molecule. Now in this time, the oxygen double bond comes to the middle. And then you share, people, hydrogen for the others. Hydrogen for the others. Right? Hydrogen you can share for the others. So this is the structure. This is the structure. And then here, people, this carbon atom. This is the, what do you call this carbon atom? We say the carbonyl carbon. We say that this one is the carbonyl carbon. Carbonyl carbon. Carbonyl carbon. Right? This is carbonyl carbon. And then we said that this whole group is aldehyde. This whole group is aldehyde. And then what do you call this, people? This group is the keto group. Keto group. Aldehyde, we took it as aldo group. Aldo group and the keto group. Right? Aldo group and the keto group. Right? So this is aldo, or else you can say that the aldoses. This is aldo group. And the other one is the keto group. So depending on the carbon number, how many? Right? 3 carbon triose, triose, and this is aldo. If 4 carbon is available, tetrose, aldose. 5 carbon, pentose, and it's an aldose. Same like that. 5 carbon and ketose. 6 carbon and ketose. So therefore, we have the sugars. Actually, 2 groups of sugars are there. Aldo containing sugars and keto containing sugars. So what are the keto containing sugar? Our syllabus says fructose. And what are the aldo containing sugars? Our syllabus say glucose, galactose, glucose and galactose. Right? This is this is aldo containing sugar, but not 3 carbon atoms. It has more carbon. I think you can understand that. Right? So depending on that, we can talk about aldo sugars and we can talk about, people, keto sugars. Aldo sugars and keto sugars. Aldo sugars and keto sugars. So octoses exist in nature kelahano. Right? Normally they say people 7 carbon atoms for monosaccharide. If it become further longer, if it become further longer, right? Then further longer, then they don't exist as monosaccharide, because when the chain become too long, it's break. So octoses, nonoses, the more than that does not exist. So we don't discuss that, right? So to my knowledge, they don't exist, right? Then right, okay. Please, if you possible, people send your questions to the main chat line, right? Send your questions to the main chat line, right? Main chat line. Send your questions to main chat line. Oh, okay. Right. Now, aldoses and ketosis. Aldoses and ketosis. Two main groups, right? Two main groups. Then people we discuss monosaccharides. Then we discuss monosaccharides. This camera is crazy. It moves. Right. So we learn this monosaccharides. So this is aldose. Right. So here we discuss people aldoses. So aldoses can exist in two forms. Neither it can available as a chain-like structure and the ring structure. So which one is more stable in the liquid medium? We learn that the ring structure is more stable. And then same like that people, the ketoses can also available as a ring structure. So fructose ring structure and glucose ring structure, we can see that there is a difference present. Ring structures are different. So let's draw people those ring structures, because in aquatic medium, they exist as ring structures. They exist as ring structures, right? So glucose, rather than having a chain structure, it exists like this ring structure, right? This is the glucose ring structure. So you got to be familiar with this shape, ne? You got to be familiar with this. You don't have to draw this. No need to memorize the molecule. No need to memorize, but you have to like identify it. This is glucose ring structure. Every corner has carbon. We don't draw that. Not necessary. Everyone knows that there is a carbon atom. And this is fructose ring structure. Fructose, and as it is in a ring structure, it looks like this. Right. So carbon number 1, 2, 3, 4, 5, and 6. Carbon number. It goes like that. And here also 1, 2, 3, 4, 5, and 6. That is how you actually number it. And then you have to understand, people, this first carbon atom is the point with the carbonyl carbon. Here, people, the second carbon atom is the point with the carbonyl carbon, right? So therefore, they are the most reactive points. It's easy to remember. For glucose and galactose, first carbon atom. For fructose, second carbon atom is the most reactive point. So we call this reactive point as the reducing end. What do you call it, people? Reducing end. Why do you call it as a reducing end? Because this is the point that react with copper present in the Benedict solution, right? So people, Benedict test, Benedict's test is one of the tests that we do to identify sugars. Neither. So when you use copper ion, it's actually a copper sulfate and sodium hydroxide mix up, right? The Benedict's reagent. Benedict's reagent is alkaline copper sulfate. What is Benedict reagent? Alkaline copper sulfate is Benedict's reagent. Right. So what happened there? Copper reacts with this carbonyl part of the sugar. It can be this one or that one. Right. And then forms what, people? Cu2O. Cu2O gives a brick red precipitate. Brick red PPT. It forms a brick red precipitate. So this color change occur. So if any color change occur, the initial color is blue, ne? Copper ion is blue in color. This is blue color. So when reducing sugar present, it can be glucose, it can be galactose, it can be fructose. When they are present, they provide this group to the medium so that this reaction can proceed. So if a brick red precipitate forms, there's going to be a color change. When color change occur, when color change occur, the reducing sugar is there, right? Reducing all monosaccharides are reducing sugars. Ne? All monosaccharides are reducing sugars. Clear, ne? Clear, right? Okay. Now we will be here to discuss about the disaccharides, right? Disaccharides. Right. Moving to disaccharides. Once again, you don't have to remember the molecular structure. No need to memorize the molecular structure, right? What you have to do is just, right, be familiar with the molecule, how it appears. Now, this is how the reaction take place. This is how the reaction take place. Look at this. This is glucose react with fructose. It forms a bond here. Look at this. This forms a bond. This forms a bond between these two groups. How it occurs, people? It forms a bond like this, right? It forms a bond like that. And then you get a new bond come here, the red color part. What do you call this new bond, people? Lamai, mukadda kiyanne mekata. What do you call this new bond? This is called as glycosidic bond. Ne? Glycosidic bond. This is called as glycosidic bond. So when it forms a glycosidic bond, what we get is a disaccharide. What we obtain is a disaccharide. Now let's see, people, what happens when two glucose molecules react with one another. This one is glucose molecule. This is also glucose molecule. When two glucose react with one another, the reaction goes like this, right? And then what happens? The new bond is going to form here. This is the new bond, right? So what do you call that? This is the glycosidic bond. Ne? That's the glycosidic bond. And what do you call this resultant molecule, people? You call this resultant molecule as the disaccharide. This resultant molecule is the disaccharide. What is this disaccharide? Maltose. Ne? This is maltose. That is maltose. Right? So when two glucose react, result is maltose. When glucose and galactose react, what it forms? When glucose and galactose react, what it forms, people? When glucose and galactose react, what it forms? It forms lactose. Ne? It forms lactose. That's correct, right? Then when glucose and fructose react, what is this guy called? That one we call as sucrose. Very good. That's sucrose, right? That is sucrose. Right. Then we don't have to discuss more about this. What you need to know, once it form a disaccharide, Still you can understand now. Let me color and show you, right? This one is a reducing group. Look at this. Here, you can see that there is a reducing group here. There is a reducing end there. There. One reducing end and there's another reducing end. Upon forming sucrose, what happened, people? Both reducing ends participate in this bond formation. Both reducing ends participate in the bond formation, so that the resulted fructose does not have a reducing end. But that's not the case when we talk about glucose. Look at this. This is a reducing end and this is the reducing end. So once it forms the disaccharide, one reducing end engages in the bond. This end is a free reducing end. It's free. It's a free reducing end. So what do you know about lactose and maltose? Are they reducing sugars or not? Are they reducing sugars or not? Right? They are reducing sugars. How about sucrose, people? Is it a reducing sugar or not? Sucrose, is it a reducing sugar or not? It is not a reducing sugar. It is not a reducing sugar. Ne? So that is now clear for you. That is clear. So glycosylic bonds are formed by removal of water molecules from the two adjoining adjacent monosaccharide by condensation reaction. And then monosaccharides, water molecules form OH groups. Look at these, people, how it happens. Now we're discuss regarding the polysaccharides, right? That's polysaccharide. 910, 910 polysaccharides, right? We'll try to revise as much as possible within this time period. I'm not going to extend the time, right? I'm going to finish it within the time, right? Maximum 1.5 hours. This nighttime discussion is not going to be longer than that. It's not going to affect your sleep. Neither. Not going to affect your next day school work, right? Just for a short time period, right? The midweek, right? Polysaccharides. Polysaccharides. Now, polysaccharides are biomolecules. They are biopolymers. This word. I saw that some students, biopolymers and macromolecules. Now, polymer is made up of many units, then you call it as a polymer. Eh? Made up of many units, you call it as a polymer. It's a macromolecule and a biopolymer. Macromolecule and a biopolymer. Large molecule. If the molecular weight exceeds 7,000, you call it as a macromolecule. Biopolymer means what? Made up of many repeating units, then you call as biopolymer, right? So look at this. They are non-crystalline, water insoluble, and not considered as sugars, and some polysaccharides act as storage components, and some act as structural components. Based on their function, they can be categorized as storage polysaccharides and structural polysaccharides. Look at this, will storage, starch, glycogen, structural, cellulose, hemicellulose, and pectin. Based on their architecture, some are linear, some are branched, right? So what are the given examples for linear, cellulose, and amylose? And branch forms glycogen, amylopectin, and hemicellulose, right? Now we discuss this, right? We discuss this, the polysaccharide and the structural arrangement. I drew a diagram, I drew a diagram in the class, right? We took polysaccharides. We classified the polysaccharides. Remember, we classified them, polysaccharides. Right? We classified them as polysaccharides. We classified them as linear, linear and branched. Linear and branched. Right? Polysaccharides are classified as linear and branched. Linear, I have taken, people, linear, we start here, amylose, amylose, as linear. Linear, it's coiled, but not branched. Ne? It's coiled but not branched, made up of lot of glucose units, not branched. And then I have taken people chitin. Chitin. Chitin is straight like this, straight chitin, right? Straight. And then we took people cellulose. Cellulose. Cellulose also like chitin, straight. But you know, chitin is made up of what? Glucosamine. Eh? Glucose, but NH2 part attached glucose. But this one is just purely glucose, right? And then people inulin. Inulin is fructose polymer. It's fructose polymer. These units are fructose. Fructose polymer. This one is cellulose polymer. This one is glucosamine. Eh? Glucosamine. Amylose is glucose polymer. So you can see a difference. Cellulose is a straight line. Amylose is the same glucose polymer but coiled. So there is something called as alpha glucose and beta glucose. So cellulose is made up of beta glucose and this one is made up of alpha glucose. You don't have to know that out of syllabus now, right? So you can learn it later, right? You have to learn slowly. You can't learn everything at once, neither. So there are some more to learn, people, right? So learn them slowly. Branch types we can classify. Branch types we can classify. Amylopectin, eh? Amylopectin. Amylopectin is similar to amylose, but you can see branches are there. You can see branches present. Amylopectin with branches like this. Amylopectin with branches. And then similar thing, these are glucose, huh? Sorry, glucose polymers, right? And then people, glycogen. Glycogen is actually similar to amylopectin, but more branched. Ne? More branched like this. More branched like this. More branched like this. More branched, right? Heavily branched than amylopectin. And then people, we said that hemicellulose and pectin. Eh? Hemicellulose and pectin. Hemicellulose and pectin. Hemicellulose is also branched. Hemicellulose is branched. We drew it like this. Ne? Hemicellulose is branched. Pectin is also branched. Right? Now, the construction material is different. Hemicellulose, what we said, people, pentose and hexose sugars. Ne? Pentose and hexose sugars. And then this one is pectin, galacturonic acid. Ne? Galacturonic acid. Galacturonic acid. Galacturonic acid is the galacturonic acid is the monomer. So this is what we discuss about people polysaccharides. And then we discuss in general we discuss about the functions, ne? Functions of carbohydrates, right? Energy source, building blocks, monosaccharides, ne? And then components of the nucleic acid, DNA, RNA. Can you tell me the component of DNA, RNA? What is that sugar present as a component? What is the sugar present as a component? Right? Ribose sugar and deoxyribose. Ne? DNA has deoxyribose sugar. RNA has ribose sugar. Both are pentose sugars. Disaccharides, storage sugar in milk. And then translocation in phloem, storage sugar in sugarcane. Ne? The polysaccharide, storage polysaccharide. And then starch to in plants and chlorophytes. What are chlorophytes? Can you remember about chlorophytes? Can you give me an example? What do you call simply chlorophytes? What do you call? What do you call chlorophytes in simple way? What do you call? Green algae. Ne? No, don't say algae. Right? Say what? Green algae. Right? Jaya Prakash, you're correct. Right? Green algae. Right? So say that. Glycogen stores in animals and fungi. That's like a special point. Ne? Fungi, right? Fungi are having what people? the glycogen, right? So if you see a fungi, he has glycogen. Inulin stores fructose as energy source, right? Inulin. Structural polysaccharide, cellulose is a structural polysaccharide. Pectin present in middle lamella, hemicellulose present in the cell wall, chitin in the cell wall of fungi, and exoskeleton of arthropoda. Right, people? So this is what we discuss. This is what you learn. Okay. So I'm not going to take further time today. I think it's enough. You study lipids, go through that. Maybe we can have a discussion of lipids later in the next class. So we'll prepare a paper from these information, right? Chemical basis elements, and then water, and then carbohydrate. Right? It's like people, the couple of months work, right? At least 2-3 weeks we discuss these things in the theory class. Now you are fast. That is the advantage, right? Every time you study, you become faster, right? In memorizing and right, getting the learning, it's faster. So repeatedly do it. This lesson we are going to discuss again, once again, people, some other time. Right? We'll have another quick revision on this, right, with couple of other sections. I think this is quite productive work, right? And so stay with me, hang on with this work, and then people will meet one another in another day. So Saturday, don't forget, we are in the enzyme last part, and tell your friends we are starting the photosynthesis lesson week after, right? Not this Saturday, but week after we are starting photosynthesis lesson. So share this information with your friends. It's a big help, right, to the students as well as for me. I'm sure you're going to do it for me. And we'll see in the weekend class, right? So good night and have a nice time. Salute for all of you.